So again, I want to welcome everyone to another MSSLC webinar, and we have a great one lined up today. At this point, everyone is familiar with the fact that solid-state street lighting is being installed by the thousands, hundreds of thousands, in fact, around the country. I think everyone's also pretty familiar with the kinds of energy savings being achieved and how prices have plummeted for these products over the last few years. But one area that we still don't have much data on because of the continuing newness of this technology, relatively speaking, is how these units are faring out in the real world and what kinds of impacts they're having on owners' maintenance programs. LED products are often touted as being maintenance-free, but this is all based on projections of long life and reliability due to the solid-state construction rather than any actual experience. That's because we simply don't have that experience yet. As of today, we still don't have even a single complete life cycle of these products to speak from, since most installation programs really only began in earnest within the last 5 years or so. On the other hand, by now those programs have cumulatively resulted in a fairly substantial population of these units in operation. So we thought it's a good time to start taking a look at the experiences folks are actually having with them in real installations and what kinds of changes to their maintenance practices they're already realizing as a result. This information should be very useful to others also considering a transition to LED street lighting and help them benefit from whatever lessons learned and best practices that the experienced users can give them. One point I want to emphasize is that today's webinar is focused on maintenance practices. All of these projects that you're going to hear about today have achieved energy savings greater than 50% with their transition. That's more than half. But we won't be spending any time on those aspects of the projects today or on related topics like comparisons of illuminance. We're going to have plenty to fill up our hour's worth of presentations already. So today, we are very pleased to have as our speakers Glenn Cooper of the City of Boston, Stephen Crume of Seattle City Light, and Patrick Batte, City of Las Vegas. I'm going to introduce them all together right now, and then we'll run directly through their presentations without further interruption. Glenn Cooper is the Director of Streetlights for the City of Boston. Glenn has held this position for the past 4 years, but has worked in the street lighting section for 30 years and has researched LED lighting to the point where it is now being implemented across the city. Following Glenn will be Stephen Crume, who is the Joint Use Engineering and Streetlight Engineering Manager within Seattle City Light. Steve has been actively deploying the LED conversion project as well as initiating plans to rebuild the city's aging streetlight infrastructure. Steve has been at City Light for 15 years, coming from a Navy career before that. And our final speaker will be Patrick Batte, a project manager for the City of Las Vegas Department of Public Works. In 2009, Patrick was directly involved in the city's testing and replacement program for transitioning 40,000 streetlights to LED technology. Patrick continues to receive input from streetlight engineering and maintenance staff to update and improve the city's current streetlight specification standards and product inventory database. So with that as introduction, let me ask Glenn Cooper of Boston to please begin.
Thank you, Bruce. Good morning, good afternoon. Again, I'm Glenn Cooper. I'm the Associate Electrical Engineer of the City of Boston Public Works Department in the Streetlights section. I'd like to thank the organizers of this webcast for the opportunity to speak at this webinar and to discuss the LED conversion program that is currently taking place here in Boston. It has been an ambitious project that will benefit all the citizens of Boston and beyond. But right now, I'd like to take some time to talk about where we currently are in our conversion and then discuss some of the lessons that we've learned thus far. As of the end of March, the city has installed over 33,000 LED streetlights throughout the city of Boston. This program started in November 2010 and has been seeding at a rapid pace since its inception. As you can see from the slide, we intend to have an additional 10,000 units installed by next June and to have the program completed by June of 2017 when all 64,000 lights will have been converted to LED. Obviously, improvements in LED technology will drive this program going forward. Every unit installed in Boston up to this point is under warranty by the manufacturer. Up to last year, all luminaires have come with a 5-year guarantee. The guarantee includes all components, including finish. Any unit that is defective is returned to the manufacturer for a new complete replacement, not a repaired unit. All shipping charges to and from our facility are paid for by the manufacturer. As of last year, we're now specifying 10-year guarantees, in fact, 10-year complete guarantees on any unit that is proposed for the City of Boston. The first of 4 successful phases of the conversion took place between November of 2010 and March of 2011. 3,000 Cobra head lighting units were converted on residential streets. Of the 3,000 units initially installed, 97 units have failed, which equate to a defect rate of 3%. Without giving the manufacturer's name, this is a typical unit that was installed in the first phase of our conversion. The second of 4 successful phases of conversions took place between April of 2011 to November of 2012. 20,000 Cobra head lighting units were converted not only on residential streets, but also on commercial and main streets in Boston, where sodium vapor streetlights existed. Of the 20,000 units initially installed, 156 units have failed, which equates to a defect rate of 0.8%, which I believe is phenomenal. And again, a typical unit that was installed in the second phase of the conversion. The third phase of the 4 successful phases took place between November of 2012 and April 2013. 3,000 Acorn-style lighting units were converted primarily on residential streets in the downtown area of Boston. Of the 3,000 units initially installed, 88 units have failed, which equate to a defect rate of 2.9%. And this installation of the Acorn lights was the first on our metered lighting system. We began savings immediately after installation due to the service being metered, unlike the first 2 phases where we had to wait months for energy credits from the utility. And again, this is the typical unit that we installed in the third phase. The fourth phase, this is the current phase that we're working on. This phase is replacing dated rectilinears or shoebox linears. A total of 10,000 units lamp with mercury vapor and sodium vapor units are now being converted. We've had a very low defect rate in these units thus far, with 6,000 units being installed to date. As of today, 30 units have been defective. So again, it's a 0.5% defect rate, which again is phenomenal. At this point, I'd like to take some time to acknowledge the entire staff here at the City of Boston Lighting Section for all the hard work that they've performed. And as of today, without their hard work and dedication, we wouldn't be even close to where we are today on this conversion. Now what you see here is a typical unit that's being replaced. It's a black shoebox that's in front of that, what we call triple decker here in Boston. And the replacement unit, as you see right there in that slide. It's a good time to note that when we specify luminaires, that they be built around a platform designed exclusively for LED lighting. We've heard many horror stories about luminaires being built around old HID technology that have dreadfully failed. I'm sure by this time that this practice has dropped significantly, but anyone who writes specifications should make this a provision in their specification. They should also consult with the Municipal Solid State Lighting Consortium website for model specification for LED lighting. It's a great resource for anybody that's writing a specification. The first part of maintenance practices is the design of the LED to ensure that they are easy to repair and replace. With that being said, not all luminaires are created equal. Specifications need to be clear and concise to ensure that the products being delivered by the manufacturer are of the highest quality. Anything short of that, the project will have issues. Even with the best specifications, issues do arise during installation. Minor issues that have arisen during installation, but I will say manufacturers have stepped up to the plate when necessary to correct and even change the manufacturing process for the city. A majority of LED failures thus far here in Boston have been with the driver. The manufacturers have replaced them without question. Other specific defects that we've seen thus far, one manufacturer had exhibited leakage into the LED array, which caused the light to fail. Another manufacturer's unit exhibits what we call flash or strobe effect. This is currently being investigated between the city and the manufacturer of this particular fixture. What has happened here in Boston, there has been a rise in what we call major system failure, which we attribute to the aging infrastructure here in the city and is not related to LED installations. And all these cases are being handled on a case-by-case basis. The impact of LED conversion is definitely starting to show up in the number of complaints. The number of complaints for outages has dropped by 1/3 due to the installation of LED streetlights since 2010. As the conversion presses forward, we anticipate that this number will continue to decline. Complaints about color and the intensity of the light come in. LED lights have a much better uniformity than its HID predecessor. Constituents were used to seeing a pool of light under the streetlight that no longer exists today. After discussing with each constituent about how LED lighting works, generally they are satisfied. With LED lighting, uniformity has increased. Most HID installs here in Boston were in the 3 to 4 to 1 uniformity range. Now at the same spacing and pole heights, we're getting uniformities of between 2 and 3 to 1 uniformity, which is great. Along with a high CRI, law enforcement has even stepped up and approved this conversion. This light does help the police identify colors, which appear much better than under a typical sodium vapor light source. Impact on inventory. For Boston, at this point, it's a twofold process. We're in the process of a new facility being designed and built for us. In preparation for this move, we've been aggressively reducing our inventory by disposing of obsolete material and auctioning it off. That does have value. We intend to reduce our inventory by 30% to accommodate our temporary facility, which is smaller than our existing facility. At our temporary facility, we will be implementing a Kanban inventory system to better track material usage by our staff. We will also be looking into barcoding our materials prior to our move to the new facility. This system will give us real-time inventories that we can make strategic decisions for future lighting products. The future inventory. This is the great unknown. With the constant change in LED technology, we're unsure how the future street lighting stockroom will look. We can make some assumptions based on current trends. We will definitely have an inventory of complete luminaires for replacement units that reach the 70% threshold or have failed and are in need of replacement. We will have an inventory of LED drivers. The luminaires that we presently have contain no hazardous products and can be readily disposed of. Those units not at 70% will be worked on in our shop and will be repaired and reissued for installation. We assume, and this is a big assumption, that the number of drivers that need to be manufactured will drop as standardization continues. Driver technology needs to advance along with LED efficiencies. We will see an increase in infrastructure inventory as we switch from maintenance of lights to maintenance of infrastructure. The items that we anticipate are the last bullet point on the slide, such as cable, connectors, conduit splicing kits. Recommendations. Those who are looking to convert to LED should look at their existing infrastructure. Any old component that needs replacing should also be done at the same time. The LED is the new spark plug. If it's hooked up to an old engine, the engine will fail if it is not addressed at the same time. Use long life photocells. It may cost a few dollars more at the beginning, but in the long run, you will save money. And we are in the process of writing such a specification for these photocells here in Boston as well. House shields. Very important in areas where there's very little frontage between the house and the streetlight. And last but not least, at least here in Boston, this is what we're doing. Specify the same color temperature on all of your luminaires that you propose to use. Uniformity in color will go a long way to a successful conversion. With that, again, my name is Glenn Cooper, and I want to thank all the participants and hope that this presentation is informative and thought-provoking. With that, I turn the webcast back to the moderator. Thank you.
You have Steve Crume here from Seattle City Light. and I want to thank PNNL for putting this webinar together. This is one of those topics that has a wealth of information and a lot of new opportunities that we're still learning. And through this webinar, hopefully we can prevent others from, taking the wrong path and learn from others' experiences. So with that said, I want to share with you City Lights LED conversion story. Okay, this slide represents a breakdown of the types of lighting here in Seattle. About 48% of our system are all residential lights. 37% are arterial, which is principal and collector arterials. And the balance is pedestrian and decorative type lighting. One thing that's important to note is we have 85,000 total fixtures, and street lighting is actually City Lights' 5th largest customer. Okay, some of the existing maintenance costs of an HPS system. We are currently on a 4-year relamping cycle where we relamp 21,000 lights per year. This is before we started the LED conversion, which those numbers are now being reduced. But at that time, the annual cost for labor and materials was $1.4 million just for labor and material. And the O&M cost of a high-pressure sodium system is actually totals $14.4 million. $13 million of that is devoted to operations, and the $1.4 million from the previous slide was the maintenance factor. So it's a total of $14.4 million annually. Okay, and some of the difficulty in maintaining, a fully operating system is there's a very slow repair response rate that we experienced in the past. Street lighting is probably one of the most visible faces of an electric utility that you can imagine. And up to 4 months, it was taking us to respond to one street light outage. Before we started this program, there were over 5,000 trouble tickets in the queue. And this is kind of the foundation that we established to start our group relamping program to reduce those outages. All of our installed HPS fixtures exceeded their design life, which the design life was 25 years. So we had to make a decision. We either go out there with a major capital investment to replace all the high-pressure sodium fixtures that were beyond their design life. It just happened to coincide with advances in LED technology, so we presented together a very good business case, and we moved down the LED path. Seattle is part of a municipal government. City Light is one of those departments. And these are some of the bullet points that are in the Mayor of Seattle's accountability agreement. And that's to improve customer service and predictability. And in 2010, we streamlined the intake process for streetlight outages. This was done to help resolve the 5,000 outstanding streetlight outages, where we have to respond to a streetlight outage, or 90% of streetlight outages within 10 business days. And then the next one is continued conservation and environmental stewardship leadership. And a byproduct of an LED conversion program is we are currently saving 20,000 metric tons of carbon per year, and that's due to reduced maintenance trips and things of that nature. And then enhanced organizational performance. And one of the factors, or actually one of the results, is Seattle City Light was awarded the J.D. Power Award for medium-sized utilities here on the West Coast in 2013. So where it all began was in 2009. We started exploring LED technology, and we wanted to address the longer life of the fixture, reduce the maintenance. They had to be energy efficient, and we wanted a wider light. Under HPS lights, you know, the CRI, or color rendering index, is at 25, whereas in our specification, the color rendering index is a minimum of 70. And we standardized our correlated color temperature at 4,000 degrees plus or minus 300, and that is for all fixture types. So as part of our business case to the Seattle City Council, we started with the concept that we needed to reduce energy consumption by 40%. We wanted to reduce the carbon footprint, lower maintenance costs, which is an O&M function, improve customer service, increase system reliability, and improve operation on bridges. Bridges are prone to vibration failures. Most of our high-pressure sodium fixtures were installed in the 1980s, and we're at the end of their useful service life, so the timing of it couldn't have been better. So we could invest our funds into the LED conversion program. The Seattle City Light actually serves more than the city of Seattle. We have several franchise cities that we serve, so it covers a huge swath of our particular area. And we started with residential conversion, which is 41,000 fixtures, mainly because that's where we could get the initial payback to get the funding approved through the City Council. And as part of the relamping program, we broke our service area up into 4 zones, and we started in the Zone 3 in 2010. We only did the upper half of 2000 for LED conversion north of the Ship Canal there. You can see it right here. And because we had already relamped the lower half of that. And then we followed the group relamping cycle. That way we could save the O&M component of that year's budget by moving in and doing the LED conversion and still relamping the arterials. We actually completed the residential LED conversion, all 41,000 lights. We completed it in October of last year, and I'm very proud to announce that we accomplished that 1 year early. Okay, here's the investment approved through the City Council that we have spent to date. We started off in 2010, which is our initial year, with $2.2 million. And then it kind of there was a major investment the next year, and then we've kind of steadied out about $4.5 million a year. And these are our unloaded costs. This slide actually represents how dramatically the prices of LED fixtures has fallen. In 4 years, the fixture cost itself has reduced by more than half. I think currently we're spending $174 on residential fixtures, where we started at $390. This chart is a comparison between kilowatt hours and dollars, savings between HPS and LED. If you look at the top of the slide, that's your high pressure sodium fixture, and we standardize the rate to today's rate so we can compare apples to apples. But you can see down at the bottom that we're currently saving $2.6 million a year in operational savings, and we've reduced the demand by almost 15 million kilowatt hours annually. This is actually one of the slides we used in our presentation to the City Council when we first started our LED conversion program. With the City Council, they want to see how much money they're going to save. And so we projected it out, and it's right around $2.5 million. The previous slide showed $2.6 million because we've had some arterial conversions since then. And we were factoring in about $250,000 annually to go in and clean the fixtures at their half-life cycle of 7.5 years. There's not a whole lot known on this at this time. We haven't started planning it. We're going to have to start probably in 2017 if that's the course we decide to take. So it's kind of some timelines. 2013, we did finish our residential conversion, and we moved right into arterial conversion. We started last year with 1,800 units, and we focused primarily on some of our franchise cities and some of our bridges. And then our arterial program will run through 2018 by the time we finish. We have about 38,000 of those fixtures to do. It's a little bit slower process on arterial streets. You have parking concerns and traffic, so sometimes we have to work at night. And then in 2019, we'll move right into our decorative and pedestrian and floodlighting LED conversion. We're actually already modeling some of the pedestrian scale lights. We have had an initial cut with the Seattle's Historic Preservation Board. We will reduce the 67 fixtures down to current 37, and we hope to land on 10. Here's some of the lessons learned that City Light has accumulated since 2010. People were unprepared for the change from back to a white light source, so it was a stark contrast to what they were used to with the high pressure sodium. But one thing that's kind of interesting is we prepared the City Council for about a 20% complaint rate, but actually what we were realizing is less than 2%. And actually our complaint rate is lower today than when we converted from mercury vapor back in the 70s to high pressure sodium. But some of the issues that are raised from our customer base are the color quality. A lot of people seem to think that the color temperature is too high. But most of those complaints were actually during our pilot phases where we were experimenting with higher color temperatures. Light trespass is actually a very big issue, especially when you have very small setbacks of buildings or houses, and especially when bedrooms are toward the front of the house. So our remedy, and as part of our specification, is that the manufacturer needs to have a field installable house side shield. And then our fixtures also have 3 different drive currents available by a simple move of a quick connect. And they come at a default of 525 milliamps. We actually did have one compatibility issue between the fixtures and PE cells, and it turned out the difference in the gasket materials between 2 different manufacturers. One of them used a neoprene, and the other one used a plastic foam material on their gasket for the PE cell. And we were getting some false locks because we had several outages reported to us in an area that we just recently converted. And on investigation, we would go out there and the photocell wasn't fully locked into place. So actually what we did is that we settled on the plastic foam because the neoprene was the culprit, giving you a false lock indication. Some of the other things that are kind of important here is our failure rates out of the box since we started the LED conversion are less than 0.2%. And last year, in 2013, we only had 1 failure out of 10,000 units installed last year, and it was just a missing screw on the terminal block. So we're very, very happy with our manufacturers and the quality control that goes into it on the factory floor and in our receiving department. One thing that we did experience in 2011 is that we did have some RF interference problems with our cable TV provider, and it turned out that the fault was actually caused by City Light because we implemented a change to the fixture halfway through production. So the factory was in a hurry to please us, and they didn't have the proper RF shielding. So we learned that lesson the hard way, and hopefully you won't. But Coupled with our LED conversion, we have also reduced our streetlight stock already by 38%, and I expect to achieve a lot more than that in the coming years. This slide I pulled from another presentation, but I thought that it was very valuable to leave in here, is that you have to take your maintenance and handling and adjustability concerns into account as you're developing your specifications and your standards. We're fortunate to have the lighting design lab right down the street from our office here, and we use the lab to confirm light levels to support the manufacturer's claims. And then we also evaluate each fixture for ease of handling. And we actually use our crews as part of that. So here, take this fixture, tell me what you don't like about it. How easy is it to level or to tilt? Is the terminal block too small? What about workmanship? On this slide, you'll see some of the things that that we've encountered. The picture on the left, you can see the broken hinge right here, and this would happen in the lab. And then also had some pinched wires on the maintenance door. And then the photo on the right, that one there is a broken photocell receptacle. When we tried to twist in a shorting cap, it broke right off. Here's some other maintenance considerations. I know the previous presenter mentioned that they were obtaining a 5-year warranty. City Light was successful in negotiating in a 10-year warranty on all new luminaires with all of our manufacturers. As a matter of fact, we included it in our specification. If they didn't want to accept the 10-year warranty period, then they chose not to bid. But we didn't have anybody decline because of that. Also, make sure that you use 20-year light photocells. You don't want to put an LED fixture out there that might last 15 years with a 4-year photocell, because the end game here is to save your maintenance costs. You also, we've noticed a significant reduction of load on our street lighting circuits. We are currently experiencing one overloaded circuit up in the University District by the University of Washington, and that's mostly due to some major transportation construction activity. But one way that we were able to reduce the load on that particular system and make it more reliable is that we accelerated that area for LED conversion. All of our major bridges are already converted, and actually on a high pressure sodium light, your life expectancy is probably only 1 to 2 years if you have a bridge that's prone to vibration. LED conversions and group relamping combined have reduced our outages from thousands. I think I said earlier that we had 5,000 when we started, and we average less than 200 today, and those 200 are all high pressure sodium lights that have not yet been converted, and the police love them. We get requests all the time from the Seattle Police Department about accelerating some LED conversion in trouble-prone areas. Here's some other resources at your disposal, very valuable, and the MSSL has some fantastic tools for modeling and support your business cases for your conversion efforts and for the reduction of maintenance. And that is going to conclude my part of the presentation.
Well, again, my name is Patrick Batte, and I'm a project manager for the City of Las Vegas Department of Public Works. I would like to thank those responsible for this webinar and the opportunity to share our story of LED maintenance issues with all of you today. I also want to acknowledge our departments of sustainability and public works. Without the collaborative efforts of both of these departments, conversion to LED lighting in our city would have not have occurred as timely as it did. Some facts regarding the City of Las Vegas. Noted that there are approximately 54,000 streetlights, of which 40,000 have already been converted to LEDs since May of 2013. 14,000 HPS lights still remain. Of those, about 4,000 occur at intersections and 10,000 are decorative standards, non-Cobra types. Of the 10,000 decorative lights, there are 4 various round types and sizes, and about 1,000 of the 10,000 are an acorn fixture. I want to remind everybody that all of our 19,000 residential fixtures have been changed to LED. All the lights in the city of Las Vegas are on a utility meter. Las Vegas is not its own power provider. This is a copy of our GIS map showing our 19,000 LED light fixtures that were converted in May of 2013. This is the GIS map of the city's 35,000 commercial lights that occur at major collectors and arterials. During the testing phase of our conversion to LED, streetlight staff and engineers from surrounding jurisdictions and, of course, the city of Las Vegas participated in a collaborative effort to evaluate each fixture type in a laboratory setting. Our primary goal during this work session was to troubleshoot maintenance and safety issues inherent in each design. This exercise proved very valuable by mitigating service and maintenance issues later in the field. I want to point out today the importance that the City of Las Vegas placed on maintenance during our evaluation and selection process. As you can see from our 5 scoreboard categories that I have above, the maintenance savings, which are a fraction of our power savings, were just as important. Our approach considered the service and maintenance of the fixture as a safety first for our public and the staff. And as we drilled down on maintenance issues, it became clear to us that sound maintenance of the fixture coincided with sound safety procedures. Here we have some of the criteria in our specifications that apply to maintenance. Notice item M11 regarding sharp corners. Again, this applies to both safety and maintenance of the fixture. Item M10 in red required an external bubble level at the base of the fixture. The bubble would enable crews to externally visually inspect, looking up at the fixture and see if the fixture was level after it was installed without the need to go up and open the cover of the fixture physically. We later discovered that the bubble on the external cover of the fixture didn't help very much during the install when the cover was open. So we did away with that feature on second and third generations. Would have been probably better to have the bubble on the top or away from the cover. One other item is that we required a 7-year warranty period on all parts within our fixture. This slide shows each of our 5 finalist fixture scoring in each of 5 categories, as I previously mentioned. It appears on this scorecard that fixture C had some serious maintenance issues with our evaluation team. This is our replacement schedule for the 40,000 LED lights. Our total timeline is about 3.5 years. 2 years was spent primarily on programming, procurement funding, and selection testing. The installment occurred over a period of 1.5 years. So what are some of the maintenance lessons learned during our conversion to LED streetlights? First, I would recommend be prepared to find field issues with all of your circuits and equipment. What we found was that there was some bad wire, of course, in some cases, and wire so large that crews were unable to properly fuse the fixture at the terminal block. What we did to resolve that issue is we requested that the manufacturer provide a UL listed fuse integrated in the terminal block and that solved the issue. Wanted to point out with my cursor here that that's the terminal block, and what we had is our manufacturer made a fuse that was integral to that, so that when the wire from the tendons came in, they were able to properly secure it. Now, we still have some issues with light trespass. It's sharply decreased since the conversion. However, homeowners often discover that their property is no longer illuminated as it was with HPS. What we do is we explain to each inquiry that streetlights are intended to illuminate the public domain and not personal property. If we still have requests of light entering a home or a bedroom, for example, we can shield that, although the City of Las Vegas does not use shield. Instead, a reduction of unwarranted directional light is achieved through masking methods such as tapes or painting of the lens, and our current methods have proved to be successful. To date, even here in Las Vegas, heat dissipation with that method has not been an issue. The bubble level requirement was explained on the easier slide. I do have to say that cul-de-sac areas here in Las Vegas, and it's pretty predominant here in the West in California, where we have a lot of cul-de-sacs in residential areas, we've experienced a coverage issue with the wide Type 2 and Type 3 roadway photometrics. In the future, I think what we would do is look at a photometric pattern that would be round, and that would provide better coverage. As we all know, trees and vegetations and even birds can still cause maintenance and illumination problems in the field. In Las Vegas, lights are inspected and serviced if necessary. There is currently not a program for cleaning the lights. Prior to LED conversion, service calls and outage complaints were running about 300 calls per month. After the conversion, calls have dropped to about 50 per month. Staff has had more free time to assist with our traffic signal division. Warranty returns are rare, less than 0.5%. As I previously stated, several of our streetlight staff have been reassigned to our traffic signal division. Some of the staff now is available to repair upgrade deferred infrastructure problems. At last, our inventory has decreased, and so has our warehouse area. We have seen about a 30% reduction due to less parts being stocked, and we're very, very efficient with our ordering process now. And one other thing is that our streetlight database is now correct and currently matches our field conditions. This slide represents our public lighting budget prior to LED conversion in 2010 and after conversion last year in 2013. As the graphs represent, lamp replacement costs, shown in red, have decreased by $400,000 since our conversion to LED. We still have some minor lamp replacement, as I explained earlier, with our intersections and some decorative lights, but it's very small. We also have a reduction in service issues shown in green by the graph, such as wire and photocell problems. This is due to corrective actions taken during the LED conversion period. We also have recorded a reduction in wire theft since the conversion to LED. So our city is currently saving approximately $400,000 per year by no longer sending several crews into the field every day with the task of just replacing HPS lamps. Now, I'm going to discuss in further detail maintenance savings from lamp replacement. We know that power savings provide a 10-year payback or better on initial capital expenditure for a conversion to LED. However, what financial opportunities are now available due to an extended LED replacement cycle over HPS? How can maintenance savings be used to pay for a future LED retrofit? Prior to our conversion to LED streetlights, the City of Las Vegas did not have an HPS relamping cycle every 4 to 4.5 years. Instead, as explained earlier, approximately 7,000 HPS lamps were painstakingly replaced each year at a cost of $400,000. Before you, I have two graphs. The upper graph, a stair graph, represents the cumulative lamp replacement expenditure comparison of HPS streetlights, shown in blue, versus LED, shown in red. Each blue step of the stair graph indicates our city's previous approach of a $400,000 yearly general fund allocation for HPS lamp replacement. Now, starting at our first LED replacement year of 2013 and deferring that retrofit until year 10, 2023, we will achieve over that period of time $4 million of savings over the previous HPS funding cycle. Again, to simplify costs, currency amounts are in today's dollar and don't include future market factors. The lower bar graph indicates our annual general fund allocation budget we had when we were still replacing HPS lights, shown in blue, versus our current LED budget, now shown in red. It's easy to plan if you were on HPS, but the question is now, how can we fund a $1.6 million LED replacement over 3 years? Well, my approach is, let's start with a bucket. Call it our maintenance savings. Now, as indicated on the bar graph, let's place our previous HPS replacement cost of $400,000 each year into the bucket. Now, let's say we have a financial advisor that's growing that fund for us at 4% each year. By year 10, the $4 million that we had in our bucket is now $4.8 million, enough to fund our 3-year LED retrofit project. Actual retrofit cost was, less the earned income of $800,000, and the cumulative HPS expenditure of $5.2 million is $1.2 million. And that can either remain in the bucket to grow for our next LED replacement cycle that we're going to have. The bottom line is, land replacement savings of a previous HPS program, use that as contributions into a reserve fund for your future LED retrofit. Also, as shown, being able to defer the less frequent LED replacement cycle versus HPS can provide a more diverse and flexible financial opportunity for your jurisdiction because of the longer life of LEDs. Well, for us here at the city, it's no longer doing business as usual. Long-term planning as a result of a future LED retrofit has forced us to be smarter and not postpone issues, hoping that somehow our power savings are going to pay for a future LED replacement. But my advice is that you've got to plan ahead and work with the lighting industry to provide a safe, easy to change, cost-effective retrofit kit or integral fixture to replace your current inventory of streetlights in the future. And one other issue that I have to raise here is that at this time, we can only assume what the cost of the future retrofit of LED will be 10 years from now. Other concerns are what you can do with the current LED materials in the future. Can you just ground those up and use them for salvage? And another thing to consider is, what about the future cost of solid state metals that are in our LED fixtures currently? This is the future, and we're looking at it, and the city of Las Vegas will start to replace our remaining intersection lights, possibly by adding additional arm on each pole, so that in lieu of having 4 HPS lights at an intersection, we'll have 8 LED. We'll look at that for uniformity and light distribution as part of a pilot project. Bridges and underpass lights are also being replaced and should be finished by early 2015. Decorative fixtures will probably be our last phase, with tasking lighting manufacturers to come up with a retrofit kit that will work with our current enclosure configuration and also meet the approval of our Historic Preservation Committee. We also have our division, which services on-site lights at parks and parking lots, as well as parking garages, and they will eventually be converted to LED dual level type fixtures. That currently is a standard for all of our new construction. And finally, we will continue to explore the use of inverse ratio photocells with long 20-year warranties that can save us a few minutes off burn time at dawn hours. And then finally, I'd like to thank all of you who viewed this webinar, the host, our streetlight maintenance staff who assisted with this presentation. I'll be available to respond to any questions as directed by our hosts, and my contact information is listed there below if you should have any questions following the conclusion of this broadcast.
Okay, thank you. I think we've used up our time. We still got questions coming in, so as we expected, there's a lot of interest in this topic. I want to thank our presenters very much for sharing their experiences and putting their presentations together. I also want to thank everyone for participating in today's webinar. It was brought to you by the DOE Municipal Solid State Street Lighting Consortium, and we hope you found this informative.